Scientific notation. Scientific notation is a method of taking a very small number or a very large number and making it more manageable and easier to use in calculations. For example, this seems gigantic, but 6 times 10 to the 18th looks much easier to read. This is all fine and good, but how do you go from this big number to this short number in scientific notation? First, we look at a number, say 5,000. The goal is to make the decimal to be right after the first significant figure. Since the number is bigger than 1, we will move the decimal to the left. 5 is the only significant figure in the number, so we need to think of a way to put 5,000 into scientific notation without making it a different number. Well, if we want the 5 to be in the ones place, then we can say that 5 times 1,000 is 5,000. So let's use that instead. However, we still have a large number when we do this. We can't change the 5 anymore since it's a prime number, so let's look at the 1,000. We want a smaller number than 1,000, but we want really simple numbers to avoid getting confused later. We can use numbers that end in 0 that can also multiply into 1,000, like 10 and 100. 100 can fit into 1,000, but it's not good to use with numbers smaller than 100 because it would be annoying to change them into scientific notation. So let's use 10. This can work really well, as it could easily take numbers larger than 10 into scientific notation, and numbers smaller than 10 are in the ones place. We'll worry about numbers smaller than 1 later, but for now we will just deal with numbers larger than 1 to keep this simple. Well, 10 cubed is 1,000, so we can substitute in 10 to the third. So we have 5 and 10 to the third.
But these numbers are entirely different from 5,000 on their own.
So we need a way to keep these numbers together. Let's do that by saying 5 times 10 to the third. Once you know why this is done, look back at our 5,000. We can see that an easier way to get scientific notation is to bring the decimal 3 places to the left behind the 5 and raise 10 by the number of places moved. So if we have another number like 6 million, we can bring the decimal 6 places to the left to be immediately behind the first significant figure, then take it times 10 and raise it to the 6th. Now that we know how to find scientific notation for numbers larger than 1, what about when we have a number less than 1? If we have the number 0.00483, then we want to do the same as before, but bring the decimal to the right. We need to bring the decimal behind the first significant figure, 4. 4.83 times 0.001 is 0.00483. Since 0.001 is 1 divided by 1,000, we can say that it is about 1 divided by 10 to the third. So 4.83 times 1 divided by 10 to the third is equal to 0.00483, but this looks weird and it's not easily understood. Well, using math again, we know that 10 to the negative third is the same as 1 divided by 1,000, and this fits the rule we made earlier for numbers larger than 1. This way, 4.83 times 10 to the negative third is much better. This also has an easy way to turn numbers into scientific notation. If we have a number like 0.0005, then you can bring the decimal 4 places to the right, so you can get 5 times 10 to the negative 4. An easy way to remember whether the exponent is negative or not is this. Larger numbers are positive, and smaller numbers are negative. Adding, subtracting, multiplying, and dividing. When adding in scientific notation, normally numbers have the same exponents, or exponents that are similar to one another. An example would be 6.0 times 10 to the 4th plus 5.0 times 10 to the 5th. We cannot add them together as they are, because we get 9.0, but we wouldn't know what exponent to use. Also, if we expand the numbers to 60,000 plus 500,000, it would equal 560,000. Then if we put it back to scientific notation, we would get 5.6 times 10 to the 5th. So we need to find a way to get this number. This can be easily solved by changing the smaller number to be the same as the larger exponent. So we can change the 6.0 times 10 to the 4th to be 0.60 times 10 to the 5th. This way you can easily add 0.60 times 10 to the 5th plus 5.0 times 10 to the 5th, which equals 5.6 times 10 to the 5th with proper sig figs. But what if the exponents are negative? If we have 2.3 times 10 to the negative third plus 6.6 times 10 to the negative fourth, then you want to make the larger number have the same exponent as the smaller number. So that 2.3 times 10 to the negative third will turn into 0.23 times 10 to the negative fourth, which makes 0.23 times 10 to the negative fourth plus 6.6 times 10 to the negative fourth equal to 6.8 times 10 to the negative fourth. If you ever forget which number is best to change, just remember, change the exponent that is closest to 0. Subtracting in scientific notation works similarly to adding. If you take 7.0 times 10 to the third minus 6.0 times 10 to the second, change the smaller number into 0.60 times 10 to the third. So you get 7.0 times 10 to the third minus 0.60 times 10 to the third, which is equal to 6.4 times 10 to the third. So what do you do if you get an answer that is not in scientific notation, such as the product of 5.0 times 10 to the third times 4.5 times 10 to the third? Well, first multiply to find the answer. In this case, the answer would be 22.5 times 10 to the third. Next, you want to move the decimal so that it fits into proper notation. So move the decimal to the left once, then add 1 to the exponent because you moved the decimal to the left.